Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in today's session we are going to continue the chapter that we have started in the last class, that is motion in a plane. So in the motion in a plane we have started vectors in the last session, so the same vectors concept we are going to continue today and tomorrow as well. Okay, so today's targets are going to be, so we'll first see the subtraction of vectors. In the last class we have seen addition of vectors, right? So then today we'll see triangle law, subtraction of vectors, then resolution of vectors, then what is position vector and displacement vector. Okay, chalo. So as usual, for the next 1 hour or 1.5 hours, just be with me, avoid all the disturbances around you guys, and at the end it's very important to prepare your own short notes. Okay, chalo. So without wasting much time, so let's get into the today's topic. So first let's understand, so what is the triangle law? So by geometrical method and by analytical method. So I am not going to derive the formula for triangle law, because whatever the formula that we have learned in the parallelogram law, so the same formula is for the triangle law to find the resultant's magnitude and direction. So let me explain you guys. So first geometrically, let's suppose the triangle law says that when two vectors are joined in the same sense, see here. So let's suppose if I have taken, so the vector A like this, and then consider the vector B this way. This is a vector A and this is a vector B. So when two vectors are taken in the same direction, so then the resultant will be obtained by connecting the tail of the first vector to the head of the second vector, so in the opposite direction. So connecting the tail of the first vector to the head of the second vector. So this is a resultant. This resultant is going to be the magnitude of vector A plus vector B. Clear? Understood this part? Again I am saying, see here. So when two vectors are taken in the same direction, A and B, so these two vectors are taken in anti-clockwise direction. Two vectors are taken in anti-clockwise direction. So then the resultant will be in the clockwise direction, connecting the tail of the first vector to the head of the second vector. See here. So the resultant is in the clockwise direction. Understood guys? Everyone? So this is anti-clockwise, this is clockwise. Or else let me take one more. So for example, if I have taken one vector like this, so this is a vector A, consider, and then let's example, and then consider, let's suppose this is vector B. So then what is the resultant here? See here. So the vector A and vector B, they both are in the clockwise direction, I can say. So then the resultant should be anti-clockwise, connecting the first vector tail to the second vector's head. This is going to be the resultant, so which is in the anti-clockwise direction. So where, so the R is equals to A plus B. So this resultant is in anti-clockwise direction, right? So or else let me take one more example. So for example, so if I take, so the vector A is like this. Let's consider the vector A is like this, and then consider I am giving the resultant. Let's suppose, so I am giving, this is a resultant, so which is vector A plus vector B, sum of vector A plus vector B. So then find the direction of vector B by geometrical method. Find the direction of vector B, guys. See here. This is a resultant, so, and this is the vector A. So the vector A is in anti-clockwise direction. So if you are adding A and B, so that means those two vectors should be in the same sense or same direction. So which means, so the vector B should be like this. Yes or no? So understand the method. So vector A and vector B both are in anti-clockwise. So then the resultant is in clockwise direction here. See, the resultant is in clockwise direction. Yes or no? Understood the logic? So this is a geometrical method. This is a just by diagrammatic method. How do we find the resultant? How do you show the resultant? Using the triangle law. So what's the triangle law says? When two vectors are taken in the same direction, so the resultant will be obtained by connecting the tail of the first vector to the head of the second vector in the opposite direction. That's it. Okay, chalo. So now that's about the magnitude. So that's about the direction. So now what about the magnitude using the triangle law? So this is a vector A, let's suppose, and then consider this is a vector B. So now you know that the resultant is going to be this one. So this is going to be the resultant. So which is, so the vector A plus the vector B. So now let me tell you this thing. So the resultant magnitude, whether it is a parallelogram law or whether it is a triangle law, so the magnitude is going to be the same. Okay. So the resultant is going to be, so square root of A square plus B square plus 2AB cos theta. So this is a magnitude. So by analytical method, so if we derive, we'll get the same thing. So I am not going for the derivation of this. So which follows the same method as of the parallelogram law. Okay, chalo. So then, and so if this angle is theta, so if the theta is the angle between the two vectors, so then again we can write, so the tan alpha is going to be, so the B sin theta by A plus B cos theta. This will give the direction. This will give the direction. So if they mention what is this angle is not going to be the angle between two vectors. Remember, this angle, this is not the angle that is going to be between two vectors, because the head and tail are connected. To measure the angle, tail should be connected, right? So you should parallel shift the vector A to this side, and whatever this vector is there, this angle is there, na? So this is going to be the angle between vectors. This is going to be the angle between vectors. So where, let's consider that angle as theta. So where theta is the angle between two vectors, which is this one, the green color one. Understood? So the triangle law, just understand the diagrammatic method, that is geometrical method, and then analytical method, same as of the parallelogram. Just remember the formula. The derivation is also not important for your board exams. So they'll ask, if the derivation they ask the parallelogram law. Clear the triangle law, everyone? So now let's go for the questions so that you will understand even better. So the first question of today's session. So pause the video and try it on your own, guys. The resultant of two vectors A and B is perpendicular to the vector A, and its magnitude is equal to half of the magnitude of vector B. So find out the angle between A and B. Okay. So now let me do this by triangle method. Okay. So there are two vectors which are A and B, and they are saying that the resultant of these two vectors is perpendicular to vector A. So first let me draw the vector A. Let me draw the vector A. Okay, chalo. Now, so they are saying that the resultant is perpendicular to the, so let me choose the color, guys. So the resultant is perpendicular, see here, the resultant is perpendicular to the vector A. So this is a perpendicular. Now, so can you tell me the direction of vector B? If this is the resultant, obviously the second vector should be like this. This is going to be the second vector because the two vectors are in the same direction, A and B, they both are in the anti-clockwise direction. So then see the resultant, that is in the clockwise direction, opposite direction we should take. Yes. Now, so see here, they said this angle is 90 degrees. So, and one more hint also they gave it in the question. What's that? So its magnitude, whose magnitude? So is the resultant's magnitude is equal to half the magnitude of B. So let the magnitude of B be, so B, and resultant has the magnitude which is equals to, so B by 2. So the magnitude of B by 2, yes or no, is equal to half the magnitude of vector B. So now what I am doing is, let's consider this angle as theta. Let's consider this angle as theta. This is, okay, fine. So then from this triangle, as it is a right angle triangle, so shall I use this formula sin theta? So the sin theta is equals to opposite by hypotenuse. So opposite is magnitude of vector R, magnitude of the resultant, and so hypotenuse is magnitude of the vector B. Yes or no? So what is the magnitude of the resultant as per the question? They said it's half of the magnitude of vector B. So in place of resultant magnitude, I am writing B by 2 by, so then magnitude of B is nothing but B, right? So from here I can say that the sin theta is equals to here b gets cancelled 1 by 2. So for which value of sin we are going to get the 1 by 2 value, guys? So obviously for 30 degrees. So that's why the theta must be equals to 30 degrees. So now choose the option A. Yes, option A. This is where you are committing the mistake. So because they asked to find out the angle between A and B, so angle between the two vectors, this theta is not the angle between two vectors, because the tail of vector, the head of vector A and tail of vector B are connected. That's not the angle, right? So when you have to measure the angle, so they should be connected tail to tail, right? So for that, so what I am doing is, so let's parallel shift the vector A. So then whatever this angle is there, so this is the angle between vector A and vector B. So what will be this angle? If it is 30, so obviously this is going to be 150 degrees, right? So therefore the angle between vector A and vector B, it's going to be 150 degrees, not the 30 degrees. The first option they will give 30 only. When you get 30, you will just blindly put 30 degrees. Okay, so the examiner also knows that. So where to catch this guy, right? So then directly he'll give first option, you'll put it. Hey, I did it correct. Then after the result, no, your answer is wrong and you lost the 4 marks because of what? You don't know, right? So just don't commit these silly mistakes, guys. So just understand the question and think once before putting the answer. Clear? Chalo. Next. So let's take the next question. Question number 2. So what's the question says? The sum of the magnitude of two forces acting at a point is 18. The sum of the magnitude of two forces. Let the two forces be A and B. I am taking. So let A and B, the magnitude of A is A, the magnitude of B is B. So their sum is 18. So let it be then. So then, and the magnitude of their resultant is 12. So the magnitude of their resultant. So resultant is nothing but what is the resultant of vector A and B? So you can write vector A plus vector B, right? So then their magnitude is given. So which is 12. So let it be now. So if the resultant is 90 degrees with the force of the smaller magnitude. So and what are the magnitudes of the forces? So understand the question properly. So the resultant is perpendicular to the smaller force. So now here I am considering B is greater than A. So let A and B are two forces in which B is greater than A. So then A will become the smaller force. So now A force, that means A vector, I am writing like this. This is the A vector. Okay. So now, so they said the resultant is 90 degrees with the force of the smaller magnitude. So smaller vector is, what is that? A. So with this the resultant is 90 degrees. So then the resultant is 90 degrees. So the resultant is 90 degrees with the vector A. So then obviously now you got the idea, right? So what is the vector B direction? So this is going to be the vector B direction, yes or no? So the vector A and vector B are in anti-clockwise direction and the resultant is in the clockwise direction. That's it, yes or no? So now from here, so what we can do, see here. So here they said, let's do one thing. So let me use the Pythagoras theorem in this triangle. I can write, so the hypotenuse square, the magnitude of B square is equals to, so magnitude of R square plus magnitude of A square. Simply I am taking the magnitude of all these three vectors. So hypotenuse square is equals to sum of the other two side squares, right? So then from here, so let me write R square is equals to, send this A to this side, A square to this side. So B square minus A square. So from here R square is equals to, this is shall we write it as B plus A into B minus A. This is in the form of x square minus y square, which is x plus y into x minus y, right? Chal. So now they gave this is the magnitude of the resultant. So in the question they gave the magnitude of the resultant. What is that? 12. So in place of this, shall I write 12 whole square? Yes or no? Now, so and then they gave the magnitude, sum of the magnitudes of A and B. So what's that? 18. In place of A plus B, I am substituting 18. And then let's write B minus A here. And then, so here it's going to be 144, which is equals to 18 into B minus A. So from here, so we can write B minus A is equals to 144 by 18. So which is nothing but 8. Yes or no? So then, so we have got B minus A and we know what is B plus A. So can we find, so B minus A is equals to 8 and then B plus A which is equals to 18. Yes or no? Clear? Yes or no? So 16, 9, 18, 8 times, yes, correct. So then, so these two gets cancelled. 2B is equals to 26. From here, B is equals to 26 by 2. So which is 12. So if B is 12, then A will be equals to 6. So 12 comma 6. Option A is the correct option. So they asked us the magnitude of forces. So the two forces we considered as A and B. Okay, so 12 comma 6. Clear? Understood everyone? Chalo. So now the vector subtraction. So till now we have dealt with the vector addition, right? So by which methods? Two methods. So triangle method as well as parallelogram method, and that too geometrically, analytically. So analytically by triangle law or parallelogram law, the formulas are going to be same. So but by geometrical method, the diagrams, like in the triangle law, you are making the triangle with the two given vectors and the resultant. And then, so in the parallelogram law, so you are making the parallelogram with the two given vectors, and diagonal of that parallelogram will give you the resultant, right? Chalo. So now vector subtraction. Vector subtraction is also a type of addition, right? So let me clarify your doubt. So now let's suppose I am taking two vectors A and B. I am taking two vectors, let's consider them as A and B. So now the magnitude of vector A and vector B. So see here. So let me write. So two vectors A and B. So we have to find the resultant of what is A minus B, vector A minus vector B. So now shall I write this as vector A plus minus B vector, vector A plus minus B vector? So let me show you diagrammatically. So consider there are two vectors, vector A and vector B. Listen carefully. So consider there are two vectors. So those are, one is vector A and the other one is vector B. So let the angle between those two vectors is theta. Okay. Now see here. Now, so what I am doing is this, if we have to find the resultant of these two vectors, that is addition. So this is going to be the addition. This is going to be the resultant. So the diagonal. So if you draw the parallelogram properly, so then this is going to be the diagonal of the parallelogram. So which is going to be vector A plus vector B magnitude. This part is clear. So now if I need, so what is the A minus B vector? So which means vector A plus minus B vector shall I write? Minus B vector shall I write? So what does it mean by minus B vector? Tell me. What does it mean by minus B vector? This is a negative of vector B. This is a negative of vector B simply. So now I have the B vector here. I have the B vector here. So I'll simply take the B vector's negative vector. So same magnitude, negative vector means same magnitude and opposite direction. This is a minus B vector. Now to get the subtraction, so what I'll do is I'll simply add A vector and then minus B vector. I'll add A vector and minus B vector. If I add them, I am going to get the resultant. That's it. So I have the A vector and I have the B vector. So what's the angle is going to be? So this angle, shall I say it's going to be 180 minus theta obviously. This is going to be 180 minus theta. So same procedure you can follow. So you can simply parallel shift the vectors. So how do you parallel shift the vectors? So this is the parallel shifting the vector A, and then this is parallel shifting the vector minus b vector. I am parallel shifting this side. Okay, so let me write more part. So this is vector A parallel shifting, and then consider this is vector B parallel shifting. So yes or no? So we have formed the parallelogram with the vector A and with vector minus B. So then their resultant will be given by the diagonal. Their resultant, so this is a resultant which is vector A plus minus B vector. Vector A plus minus B vector. So and what is the angle between those two vectors? 180 minus theta. Yes or no? So now simple thing is, when two vectors are just adding up, so the angle between them, the resultant, we have got, so a square plus b square plus 2ab cos theta plus 2ab cos theta. So this is the magnitude of the resultant square, right? So now, so simply I can replace this theta with the 180 minus theta to get the a minus b vector. So now the a minus b is equals to the vector A minus vector B is equals to simply, so A, the magnitude I can simply write, so this is a, so the resultant, so let it be some r dash, consider this as the r dash guys, vector r dash. So then vector r dash will be equals to vector A minus vector B. So then how do you write its resultant, the vector? So simply square root of the magnitude you take. So you just take the magnitude of it. So which is going to be square root of a square plus b square. In place of b you take the minus b. So minus b whole square means again b square. So plus 2ab into, so cos 180 minus theta. Just in place of theta you take the 180 minus theta. That's it. So then it's going to be, so the resultant, the magnitude of the resultant, so which is going to be square root of a square plus b square, so cos of 180 minus theta. So first 180 minus theta lies in the second quadrant. In the second quadrant cos is negative, yes or no? So cos is negative, and for 180 cos remains as cos. So that's why, so it's minus cos theta. So minus I am bringing multiplying with this. So therefore minus 2ab cos theta, that's it. So then simply the resultant of the subtraction is just replace the theta with 180 minus theta. And if you need the direction, so what you do is, so with the vector A, it's making, the resultant is making an angle alpha, and the resultant R is making, so with the vector minus B, so beta, yes or no? So in the case of tan theta, let's suppose if it is alpha, so we know that in the case, in the starting case, so the tan, let it be alpha dash beta dash. So in the case of tan alpha, we know the formula. Let's write this way. So the tan alpha is equals to b sin theta by a plus b cos theta. A plus b cos theta. This is in the case of addition. So now if you need the direction in the case of subtraction, so we need tan alpha dash. So tan alpha dash will be b sin of, in place of theta simply substitute 180 minus theta. So by, so a plus b cos of 180 minus theta. In place of theta just substitute the 180 minus theta. Yes or no? Understanding? So now sin of 180 minus theta is sin theta only. In the second quadrant 180 minus theta means sin positive, right? So then, so cos of 180 minus theta minus cos theta, therefore minus b, a minus b cos theta. So this is the direction and this is the magnitude, that's it. So that means the vector subtraction is also the kind of simply addition. Yes or no? Understanding? Sure. So now for the vector subtraction you have to remember, so the r, the magnitude of r difference we call. So the difference of the two vectors, which is equals to square root of a square plus b square minus 2ab cos theta, minus 2ab cos theta. And then, so the magnitude, the direction if you required, so tan alpha dash or tan alpha, let it be, so it's going to be b sin theta by a minus b cos theta. So these two you should remember. Okay, simply in place of theta you substitute the 180 minus theta, that's it. Understood guys? Clear? Sure. So let's take one question which is asked previously, so in NEET 2016 and as well as APMT 1991. So what's the question says? So if the magnitude of the sum of the two vectors is equal to magnitude of the difference of the two vectors, so then find the angle between the two vectors. So the magnitude of the sum of the two vectors is equals to, so the magnitude of difference of the two vectors. That's what they said. So then consider those two vectors as, consider A and B are two vectors. Consider A and B are the two given vectors. So in that particular case, so shall I write, so some magnitude which is nothing but square root of A square plus B square plus 2AB cos theta. Yes or no? So then for the difference, it's going to be A square plus B square minus 2AB cos theta. Yes. So from here, let's do squaring on the both sides. Squaring on both the sides. So now we get, so A square plus root cancels either side. So A square plus B square plus 2AB cos theta is equals to, here also A square plus B square minus 2AB cos theta. Right. So from here A square B square cancel. So if you bring this minus 2AB cos theta to this side, it becomes 4AB cos theta is equals to 0. So 4AB cos theta is equals to 0. So from here, so let me write, so simply the cos theta will be equals to 0. The cos theta will be equals to 0. So from here, theta must be equals to, so for which value of cos it's going to be 0? So for 90 degrees. So the theta must be equals to 90 degrees. So which is option A. So remember this as a standard result, guys. Remember this as a standard result. Okay. So when the magnitude of the sum of the two vectors is equals to magnitude of the difference of those two vectors, so then the angle between those two vectors must be equals to 90 degrees. Okay. Chal. So let's move further. So let's solve one more question. So what's the question says here? Pause the video and try it on your own. A particle is moving with velocity 5 meters per second towards the east, and its velocity changes to 5 meters per second north in 10 seconds. So find the acceleration. So first the directions. So let's consider this as east. So this as west. So and then north direction and then south direction. So let it be. Now, so what they are saying, a particle is moving with a velocity 5 meters per second. So towards east. So first it's moving towards east. So with a velocity, let it be V1 5 meters per second. So the velocity is a vector quantity. Yes. Chalo. So and its velocity changes to 5 meters per second north. So then it changes to north. So then its velocity V2 will also be equals to 5 meters per second. So but in north direction. Find the acceleration. So what's the acceleration? The acceleration is equals to, we know that, so V2 minus V1 by the time taken. So the change in velocity by time taken. Sir, this is 5, we'll simply subtract 5 minus 5, 0. This is in the east direction, this is in the north direction. You can't just directly subtract the magnitudes because there is a direction for the vector, right? So now, how do you find the vectors V1 minus V2 minus V1? So for that, so let me do it here. Simple trick. So hope you guys are already got the answer. So let's consider the vector V1 is equals to 5 meters per second here. So then V2 vector, I am parallel shifting to this side. So parallel shifting of the vectors is allowed, right? So V2 is equals to 5 meters per second. Okay. Chal. So now, so I need V2 minus V1. V2 vector is here. So V2 minus V1 means, shall I write it as V2 plus minus V1 vector by the time taken? By time taken. So what is minus V1 vector? Simply with the same magnitude, so and reverse the vector. This is going to be minus V1 vector. V1 vector is 5 meters per second towards right or east. So then minus V1 means reverse its direction with the same magnitude. So the magnitude is going to be same 5 meters per second. So then what is V2 minus V1? V2 plus minus V1. So that means you have to add these two vectors. When you add these two vectors, so the resultant is going to be in this direction. What is this direction is said to be? So this is the west direction. So this is in the north direction. So the northwest direction is going to be the correct answer. So obviously you can cancel out, rule out two options. C and D are wrong. Okay. So now this is in northwest, this is in northwest. Now, so let's go for the magnitude. So if you observe, this is 5, this is 5. Obviously this should be 5 root 2. Yes or no? This is the 5 meter per second. This is 5 meter per second. When two vectors having the same magnitude and angle between them is 90 degrees, so then the resultant will be equals to, so that magnitude into root 2, last class we have seen standard result, right? So obviously here it's going to be 5 root 2. So or else if you need, you can calculate that. Okay, so square root of a square plus b square minus 2ab cos theta. In place of theta, you substitute 90 degrees. Okay, chalo. So what is v2 minus v1 here? So I am writing that as 5 root 2 simply by, so the time taken 10. So which is going to be, so root 2 by 2. So root 2 by 2 means which is 1 by root 2, because in 2 you can write it as root 2 into root 2. So therefore 1 by root 1 root 2, 1 root 2 in the denominator cancels. If you want, you can do that step. So root 2 by, so here 2 I can write it as root 2 into root 2. So root 2 cancel, 1 by root 2. So which is 1 by root 2 meter per second square northwest. Here it is given root 2. No. So 1 by root 2 meter per second square northwest. This is meter per second square. Okay, clear? Sure. So next. So let's take one more question. So let's take one more question, guys. So what's the question says here? A bus is moving on a straight road towards north. Again directions, let's take, this is the east direction, this is the north, this is the west, and this is the south direction. So a bus is moving on a straight road towards north. So bus is moving towards north, fine. So with a uniform speed of 50 km per hour. Okay, fine. So this is moving at a speed of 50 km per hour. So then it turns left by an angle 90 degrees. So it turns left by an angle 90 degrees. So without, if the speed remains unchanged after turning the, so here the speed again 50 km per hour, speed is unchanged, they said. So then increase in velocity of bus in the turning process. Increase in velocity, we have to find what is increase in velocity. So the increase in velocity is nothing but, so the final velocity minus initial velocity, simply v2 minus v1 we have to find. So the same process. So we have got two vectors. So one is vector v1. So let's rearrange these terms. So I have the vector v1. So this, or else let's write this way. So this is the vector v2, and then this is the vector v1. Yes or no? Simply I am parallel shifting this vector v2 to down. So this is v2 minus v1. So sorry, this is v1, this is going to be v2. So which is parallel shifted downside. That's it. So now what I required? I required v2 minus v1. So how do you find v2 minus v1? v2 vector is here. So I can simply write this as v2 plus of minus v1 plus of minus v1. That's it. So you got the answer now. So you can write what is minus v1? This is the minus v1 vector. Same magnitude, opposite direction, minus v1 vector. So then you have to add v2 plus minus v1. So the resultant is going to be obviously in this direction. Yes or no? So what is the resultant? So it's going to be, this is 50 and this is also 50. So this is going to be 50 root 2 southwest. This is west and this is south. So 50 root 2 southwest direction. So 50 root 2 southwest. See here. So 0, no. Along west, no. Northwest, no. So the only with the direction you can find it. So it is southwest, and then 50 root 2 means 70.7. So option A. Clear? Simply vectors concept. Done? So let's move further. So then we have got the polygon law of vector addition. So this is only by the geometrical method. There is no formula for this. For triangle law and parallelogram law, we have the geometrical method as well as analytical method, and their analytical method formulas are same. But for the polygon law of vector addition, there is no formula. So just the geometrical method will be there. So how do we write? So it's an extended version of triangle law, that's it. So what's a triangle law says? When two vectors are taken in the same direction, the resultant will be obtained by taking the resultant in the opposite direction of those two vectors by connecting the tail of the first one to head of the second one. So here also same thing. Let's suppose if some more than two vectors, when to apply this one? When more than two vectors are to be added. More than two vectors to be added. So in such cases you can go for the polygon law. So consider this is a vector A, let it be the vector B, let it be the vector C. So then if all these vectors are taken in the same direction, see here A, B, C, these three are in the, so which direction? Anti-clockwise direction. Now, so the resultant will be obtained by connecting the tail of the first vector to the head of the last vector, that's it. Connecting the tail of the first vector to the head of the last vector. So this is the clockwise direction, in the opposite direction. So this is the resultant, which is a plus b plus c vector, a plus b plus c. Clear? Chalo. So or else let's suppose if we have some n number of vectors. So consider this is vector A, consider this is vector B, so consider this is vector C, consider this is vector D, so and then consider this is vector E. So then the resultant will be obtained. See here, all these vectors are in anti-clockwise direction. So the resultant should be in the clockwise direction by connecting the tail of the first vector to the head of the last vector. So this is the resultant. So which is vector A plus vector B plus vector C plus vector D plus vector E. Hope you understood. Extended version of the triangle law. Only geometrical method. So no analytical, no formula. Clear, clear, clear. Chal. So let's move further. So let's move on to the next concept, that is unit vector. Already in the last class I gave the introduction to the unit vector. So the unit vector is the one which has the magnitude 1 and then its purpose is to give the direction. So let's suppose there is a vector A. So this vector will have the magnitude and it will have the direction. So the direction of it will be denoted by unit cap. So A cap. So A vector's direction will be given by its unit vector. What is its unit vector? A cap. So let's suppose x is the vector. So the x direction will be given by, so x vectors unit x vectors cap. That's it. Okay. Chalo. So from here, what is the, so unit vector A cap. So simply vector A by the magnitude of vector A. So vector A by the magnitude of vector A. So now in the three-dimensional space, along the x-axis, along the y-axis, along the z-axis, we have three orthogonal unit vectors. So there are I, j, k. So these are the three orthogonal unit vectors. These are orthogonal unit vectors. So what are orthogonal means? Last class we discussed. Orthogonal means which are perpendicular to each other. Okay. So the I cap is a unit vector along the x direction. So the I cap is a unit vector along the x direction. So j cap is a unit vector along the y direction. Okay. K cap is unit vector along the z direction. K cap is unit vector along the z direction. Okay. So these three vectors are mutually perpendicular to each other. So the unit vectors along x we denote it as I cap. So along y we denote it as j cap. Along y it is j cap. So along z it is k cap. For example, so let's say, so if a vector has got so some 5 magnitude in the x direction and then 6 magnitude in the y direction, 6 magnitude in the y direction. So then that vector can be represented. So consider that is the vector A. So this vector A has 5 is in its x component and 6 in its y component. So simply I can write the vector A will be equals to 5 along the x direction. Along the x direction unit vector 5 cap. So along the y direction unit vector j cap. So this vector is 5 I cap plus 6 j cap. So like that we can write. Clear? Understood? Everyone? So now as a class progresses, you will understand more. So because we are going to do the questions and all, so you'll understand even better. Okay, chal, next. So how do you resolve the vector? This part is very, very important, especially for all the chapters, especially for the mechanics. Most of the chapters in the mechanics and in the electrostatics and magnetism also, the resolution of the vectors is very important. Okay, chal. So what does it mean by resolution? See, there is a vector A. Consider this is a vector A. So this vector A is making an angle theta. So this vector is A is neither in x direction nor in y direction. It is in the xy plane. Let's suppose this is the x axis, this is the y axis. So my vector is in the xy plane like this. So in between x and y, so it is there, right? So let's consider like this. So this is the x, right hand is the x, left hand is the y. So in between the vector A is there. So then this A vector will have the x component along the x axis, and this A vector will also have the y component along the y, right? So that means this vector A has two components. As it is in the xy plane, it will have the x component, and as it is in the y component, it is in the AY is its y component. So the AX and x direction's unit vector is I cap. So and AY is the magnitude of vector A in y direction, and what is the direction in the y direction? So that is j cap. Yes or no? So or else you can do it by this way also. Let's consider. So this is vector A. So this vector A will have, if you shift this, parallel shift this y, AY is this one, and then AX is this one. From here to here it's going to be AX, from here to here it is going to be AY. So from there you can find the direction of that vector also, which is tan theta is equals to AY by AX. So the tan theta is equals to AY by AX. Yes or no? So from here you can simply write. Understanding? Yes? So or else from this triangle, if you have to write, so the sin theta is equals to, what is sin theta formula? AY by opposite by hypotenuse is vector A. So from here, so the magnitude, let's write magnitude of vector A. So then AY is going to be simply A sin theta. AY is going to be A sin theta. So this is A sin theta. Whereas the A, so let me take cos theta. Cos theta is equals to, so adjacent AX by, so the hypotenuse magnitude. Hypotenuse magnitude is vector A magnitude is A, right? So then from here AX is equals to A cos theta. AX is equals to A cos theta. So therefore the vector A can be written as AX. What is AX? AX is A cos theta I cap plus, so AY, what is AY? A sin theta j cap. A sin theta j cap. Okay. So this is a mathematical method, but the simple way you can remember, so the resolution of vectors, so that is, for example, so this is the x direction and this is the x axis and y axis. Consider there is a vector A which is making an angle theta like this. So then its x component will be equals to AX is equals to its magnitude A, and then wherever the theta is there, so to whichever the side theta is there, so that side cos component will come, A cos theta. Okay. And to whichever the side theta is not there, so that side sin component will come. See here, this side theta is not there, so that's why A sin theta. So that's why AX is equals to A cos theta and AY is equals to A sin theta. This component, x component is A cos theta, y component is A sin theta. Okay. And so the vector's magnitude can be calculated by simply its x component square plus y component square. Its x component square plus its y component square. Okay. So this is a representation of the vector in 2D. Okay. If it is in the 3D, similarly you can represent it in the 3D. Let's suppose a vector A is there in the 3D. So then we can have the vector A will have the AX I cap in the x direction and y cap, y direction, and then in the z direction. So if you need magnitude of it, simply you can write So the magnitude of vector A is square root of ax square plus ay square plus az square plus az square. Clear? So let's suppose, so we have just take one question so that you will understand better, or else I guess next question is there. So let's solve the question, you will understand better. See here. So this is 3 I cap, guys. This is 3 I cap. So the question is given wrong here. So for vector A, it's 3 I cap plus 4 j cap. So first understand the question. So the vector A is given. So vector A is 3 I cap plus 4 j cap. 3 I cap plus 4 j cap. So now I have to find, so the magnitude of vector A. So it is in the form of, this vector is in the form of ax I cap plus ay j cap simply. We know that the magnitude of vector formula is, so square root of ax square plus ay square, ax square plus ay square. So here ax, in place of ax what do we have? 3 square. In place of ay we have 4. So therefore 4 square. So 3 square plus 4 square, 9 plus 16, 25. So root 25. So which is going to be 5. So therefore the first question is done. The magnitude of vector A, it's 5. No need of options actually. So just take off the option, guys. So just take these options off. Not required. Okay, so options are not required for this question because there are 3 questions, right, in this. Chalo. So next, see here. So the next one. So what's the second question says? So the second question says the unit vector A, unit vector we have to find. So what is the formula? Vector A by the magnitude of vector A, simply. Vector A by the magnitude of vector A. So what is vector A? Vector A is 3 I cap plus 4 j cap by, so we have already got what is the magnitude of vector A, so which is 5. So I can simply write this as 3 by 5 I cap plus 4 by 5 j cap. This is the unit vector, that's it. You need not to do anything further. Okay, sure. Next. So the third question, see here, important. So vector of magnitude 2 units along A. So we have the third one. So what's the question says? So there is a vector of magnitude 2. So let's suppose there is a vector, some x vector is there, whose magnitude is 2. So the magnitude of vector x, and it will have the direction. It will have the direction. I am considering some vector x. So the magnitude of vector x is x magnitude, and then its direction is given by x cap, right? So now, so vector of magnitude 2, let's, the vector has the magnitude 2. So in place of magnitude of vector x, I am taking, so 2. And then, so along A, so what does it mean by along A? In the direction of A. In the direction of A means, so shall I take here the unit vector of A, 2 into the unit vector of A, that's it. 2 into along A means in the direction of A. What is the unit vector in the direction of A? A cap, that's it. See, understand this statement. So there is some vector, we have to find some vector whose magnitude is 2. So that vector I considered x. So that x vector will have the magnitude and direction. So its magnitude mentioned here, 2 units. So 2 I wrote here, and then, so its direction is along the vector A. Along the vector A means, so unit vector of A, that's it. Along means direction, right? So what is the direction of A? Direction of A will be given by unit vector of A. So that's why I am writing x cap, in place of x cap I am writing A cap. So 2 into, what is A cap? So A cap is 3 by 5 I cap plus 4 by 5 j cap, that's it. So from here we get 2 into 3, 6 by 5 I cap plus, so 2 into 4, 8 by 5 j cap, that's it. So this is a vector x. This is a vector x, some vector x. Clear everyone? Chalo. So let's take one more question. So what's the question says, see here. For a vector A and vector B, so find a vector having the same magnitude as B and parallel along A. So important kind of questions. See here. So for a vector A and for vector B, so find a vector having same magnitude as of the B and along parallel to the vector A. So I am considering some vector. We have to find a vector, some vector x. So whose magnitude is same as the magnitude of vector B, is same as the magnitude of vector B, and it is along the vector A. So along the vector A means vector A unit cap. That's it. Understand the statement properly. We have to find some vector whose magnitude is same as B. So that x vector has a magnitude whose magnitude is same as vector B, vectors B magnitude, and it should be parallel or along the vector A. So parallel or along the A means A unit vector. Okay. So now your job is easy now. So can we find what is the B vector's magnitude? So what is the B vector's magnitude? So vector B magnitude, so which is going to be simply square root of 4 square plus 3 square, right? So however this is going to be again 5. So the vector B magnitude is 5. And how do you find the unit vector of A? How do you find the unit vector of A? Unit vector of A is vector A by, so the magnitude of vector A. So what is the magnitude of vector A? So what is the magnitude of unit vector A? So vector A is 6 plus 8. So which is square root of 6 square plus 8 square. So this is going to be 36 plus 64. So which is root 100, which is nothing but 10. So that means, so we can write the unit vector of A is vector A 6i cap minus 8j cap by, so 10 by 10. So I am substituting that here. This is a unit vector of A and this is the magnitude of vector B, right? Simple things. Now so in place of unit vector of A, I am writing 6i cap minus 8j cap, right? So then by 10. So here 5 ones are, 5 twos are. So here I can write 6i cap by 2 minus 8j cap by 2, right? So which is 3i cap minus 4j cap. So what they are saying? So find a vector having same magnitude. So that's it. So this is a vector which is having the same magnitude and along the vector A. So here also options not required, which not, they are not matching. Just this is mistyping, I guess. Okay, done. So understand the procedure. So along means that vector's unit vector you should take. That's it. Done, everyone? Clear? Sure. Next. So find A plus B. So find the vector A plus vector B. So first here vector A is some 5 and vector B is some 10. So we have to find the components of vector A. So the vector A has two components here. What is the vector A components? It should have the x component and it has the y component. Yes or no? So what is the A vector's unit vector x component? The Ax is going to be simply, as theta is this side, 37 degrees is this side, I can write phi cos 37, phi cos 37, and then this side vector it's going to be Ay. So what is this Ay? So which is phi, so as theta is not there this side, it's going to be phi sin 37. And you know this triangle, right? So the 37 degrees, 53 degrees and 90 degrees. So opposite to 37 3, opposite to 53 4, so opposite to 90 5. So now cos 37, so 5 into cos 37 adjacent by hypotenuse, 4 by 5. So 5 cancel, Ax is 4. So similarly Ay is what? 5 into sin 37. So sin 37, sin means opposite by hypotenuse. So 3 by 5. So which is 3. So that means Ax component is 4. So 4i cap plus Ay component is 3. So 3j cap. So this is a vector A. Similarly, can we find the vector B? So vector B has also got two components. One component is this side, the other component is this side. So this component is along x, that's why AX, which is, so BX, sorry, this vector is B, right? So that's why it's going to be the x component of B. So how do we write? So the theta is this side 53, so that's why 10 cos 53, and then this component is going to be By, which is 10, theta is not there this side, so 10 sin 53. So whichever the side that theta is there, that side cos of that angle, and whichever the side it's not there, sine of that angle. So here 53 is there this side, that's why cos 53. It's there, it not there this side, so sin 53. So its magnitude into sin 53. Its magnitude into cos 53. So again, you know the what is cos 53? Cos means adjacent by hypotenuse. 53 adjacent is 3, by hypotenuse is 5, right? So here 2, so 2 into 3, 6, and then 10 sin 53. So 10 into, so what is sin 53? 53 opposite 4, hypotenuse 5. So here 2 times 2 into 4, 8. So Bx is 6. So vector B is equals to, so Bx I cap plus By j cap. So then Bx, what is Bx? See, here direction is also important, guys. So while taking the Bx, it should be negative side. So that's why minus 6 I cap you should take. Minus 6 I cap. Don't just directly write plus 6 I cap, because it is towards the left. That's why minus 6 I cap. Okay, now unit vector along the x-axis, positive x-axis is positive I cap. Along the negative x-axis, minus I cap. Okay, so that's why it's minus 6 I cap. Plus, so however it is in the positive direction, so that is 8 j cap. So then this is a vector B. So now we have to find what is vector A plus vector B. So vector A plus vector B, which is equal to what's vector A? 4 I cap plus 3 j cap. Plus what is a vector B? Minus 6 I cap plus 8 j cap. So simply respective I caps, respective j caps you should do. 4, here plus into minus, minus 6 I cap. So here 3 plus 8 j cap. So then 4 minus 6 minus 2 I cap plus 3 plus 8, 11 j cap. So minus 2 I cap, 11 j cap. Option D is the correct one. Minus 2 I cap, 11 j cap. Clear, everyone? So this is how you should resolve the vectors and you should add them. Done? Chalo. So let's go for the next question. What's the question says? A body is acted upon by 3 forces is under equilibrium. So what does it mean by equilibrium? So if the body is in equilibrium, so the net force acting on the body is 0. So net force in the sense, so the summation of forces in the x direction 0, the summation of forces in the y direction 0, the summation of forces in the z direction 0. Remember this. Whenever the body is in equilibrium, especially the translational equilibrium we say, okay, you will understand these terms as the class progresses in the LLM. So translational motion, translational equilibrium, if the body is there, so the net force acting on the body will be equals to 0. Net force means the total force in the x direction should be 0, the total force in the y direction should be 0, the total force in the z direction to be 0. Okay. So if F1 is 10 newtons, F2 is 6 newtons. Where is F1? F1 is 10 newtons. So F2 is 6 newtons. And then find the values of F3 and theta. So we have to find, this is the F3 I guess. So find the value of F3 and find the value of theta. So the body is said to be in equilibrium. The hint is equilibrium. So now see here. So first my duty is, so F1 vector has 2 components. Yes or no? So let's find the components of F1 vector. So this side it's going to be 10. So this side it's going to be 10 cos 37. Wherever the theta is there, that side cos component will come. So theta is there this side. So magnitude is 10. So that's why 10 cos 37 comes this side. And then, so this side theta is not there. 10 sin 37 comes this side. 10 sin 37 comes this side. Yes or no? So now you know the 37 degrees triangle, this triangle we know. So just write it aside for your understanding. So this is 37, this is 53, and this is 90. So then opposite to 37, 3, 53, 4, 95. So then cos 37, 10 into cos 37, 4 by 5. So which is 5 into 2, so this is 8. So then this is going to be 10 into, so sin 37. So what is sin 37? Opposite by hypotenuse. So 3 by 5. So 5 ones are, 5 twos are. So this is going to be 6. So that means, so the F1 vector is 6 I cap right side, and then upside it is 8 j cap. Let it be. Okay. So then similarly, can we write the components of vector force 2? So force 2 will have two components. One is this side, the other one is this side. Okay na? So no need to write the vector also. Let's understand this way. So however, theta is there this side. I can write 6 cos theta, because we don't know what is theta. So its magnitude into cos theta will come this side. And theta is not there this side. So 6 sin theta will come this side. Okay. And the force F3 is down. The force F3 is down. So now the body is in equilibrium. Here the body is in equilibrium. So the first thing is, if the body is in equilibrium, so I can say that the sum of the forces in the x direction should be equals to 0, and the sum of the forces in the y direction should be equals to 0. So the F net on the body is 0. So the F net on the body is 0. F net means here only xy direction forces are there. So that's why sum of the forces in the x direction should be 0. So the sum of the forces in the y direction is 0. This is a summation symbol. Hope you guys already know this from the maths, right? So summation of forces in the x direction. So x direction we have 6 this side. So 6 sin theta this side. Yes or no? So x direction we have 6 this side and 6 this side, and then 6 sin theta this side. So then can we find what are the forces in the x direction total? What are the forces in the x direction? We have only two forces. One is 6 sin theta must be equal to 6. When these two are balanced, then only the net forces in the x direction is 0, right? Whatever the force that acting this side, 6 sin theta, must be balanced by this side force, which is 10. Yes or no? So 10, this is going to be sin 37. Sin 37 is 3 by 5. Yes, fine. So 6 sin theta is equals to 6, right? So from here, sin theta should be equals to, so 6 by 6. So from here, sin theta is equals to 1. So then the theta must be equals to 90 degrees. The theta must be equals to 90 degrees. I guess some value wrong. Huh? See here. So this is 10 newtons. F1 is 10 newtons only. Na? This is 10 newtons they said. This is F2 they said. This is F3 they said. Okay, fine. So F1 10 newtons means 10 cos 37. So cos 37 is 4 by 5. So then 4 into 2. So okay, fine. So this is okay. So this magnitude, F2 magnitude is 6 only, na? Yes, 6. So 6 this side, sine component will come, this side cos component. Yes, okay, fine. So this angle should be 90 degrees. And then, so the summation of forces in the y direction should be 0. So what are the forces in the y direction we have got? So upper side we have 6 cos theta plus what else is there upper side? 8 is there. Yes or no? So 6 cos theta plus 8. So that must be balanced by F3. That must be balanced by F3. So therefore 6. Now we have got what is theta value. So cos 90 degrees plus 8 is equals to F3. So from here, so cos 90 is however 0. So this whole term will be 0. So the F3 magnitude is 8 newtons. That's it. So F3 is 8 newtons. Theta is equals to 90. That's it. So that's what we have to find. Clear? Understood, guys? Sure. So now the Lami's theorem. So the concurrent forces. So I forgot about the concurrent vectors in the last class actually. So the concurrent vectors means which are acting at the same point. The concurrent vectors is nothing but so which are acting at the same point. So let's suppose if there are two forces or three forces which are acting at the same point. This is force F1. So let's suppose if the force F2. So then consider this is a force F3. These are acting at the same point. These three are the forces. Okay. So let's say this angle is let's say this angle is alpha, let's say this angle is beta, so let's say this angle is gamma. So now here is the body. On this body, these three forces are acting. So if they say this body is in equilibrium, if the body is in equilibrium, so then by Lami's theorem, you can simply write, so the force F1 by its opposite sine of its opposite angle, sine alpha, sine of its opposite angle. So then force F2 by its opposite angle, sine beta. So which is equals to force F3 by its opposite angle, so sine gamma. That's it. So this is a trick you can apply. So this is a mathematical trick, so which we can apply. So when the body is in equilibrium and three forces are acting at the same point, such forces are said to be concurrent forces. The forces which are acting at the same point are said to be concurrent forces. Clear? Everyone? Sure. So let's move further. So let's take this question. So yes, so we'll continue. So just let this lecture be a bit longer, so because we have to complete the topics as well. So let's see this question. So three forces acting on a body are shown in the figure. So there are three forces, see here. So this is the body, 1 Newton force is acting this side, 4 Newtons this side, so 2 Newtons this side. Next, so to have the resultant force only along the y direction, so the resultant force should be only there along the y direction. So that means what they are saying, the net force in the x direction should be 0. They are saying that the net force in the x direction should be 0. So then the magnitude of minimum additional force needed is, how much additional force is needed? Simple question. See here, the hint that they gave is the summation of forces in the x direction should be equals to 0. The summation of forces in the x direction should be equals to 0. So first let's write all the components. So let's use the different colors. Here, this side component, it's going to be 1 cos 60, and then, yes or no? So this magnitude is 1, and then as theta is there, this side 60 degrees is there, so cos component will come, and then this side, this component will comes out to be, so 1 sin 60 degrees, 1 sin 60 degrees, fine. So next, so this 30 degrees will have two components. So this side 4 sin 30 degrees, and then this side 4 cos 30. Yes or no? Next. So then let's use a different color here. So for green I am using. So this side, so for this one, this side we get 2 sin 30 here. 2 here, theta is not there, that's why sin 30 degrees will come this side. So this side 2 cos 30. 2 cos 30. So the components are clear. Now let's find their values. So here first 1 cos 60. Cos 60 means 1 by 2. Yes or no? So then here 2 sin 30. So what is 2 sin 30? 2 into sin 30 is 1 by 2. So which is nothing but, so 1, right? So then I need only in the x. So let's forget about the y. Okay, I need only in the x, because the hint that they gave is the forces, sum of the forces in the x direction should be 0. So then 4 into sin 30. Sin 30 is 1 by 2. So which is nothing but 2. So now see, in the x direction we have 1 by 2 Newtons force here, and then in the same x direction, positive x direction, 1 Newton, and in the negative x direction we have 2 Newtons force. So now what they are asking in the question, so the magnitude of the minimum additional force needed to make the x directional forces, or the summation of forces in the x direction, should be 0. So when the net force in the x direction 0, this side 2 Newtons, this side 1 plus 0.5, 1 by 2 means 0.5, so 1.5. So when you add plus 0.5 Newtons this side, so then the summation of the forces in the x direction will become 0. So that's why the additional force that you have to add is 0.5 Newtons. Clear, everyone? Sure. So now let's move on to the next concept, the position vector. So the position vector is nothing but, it's a position of a vector with respect to origin. Position of a vector with respect to origin. with respect to origin. So for example, so there is a point P. Okay, so let's say these are the coordinates of vector A. So that vector A has two components. See here, in the x direction it is at a distance x, in the y direction it is at a distance y. Yes or no? In the x direction it is at a distance x, and in y direction it is at a distance y. So consider this is a vector. Consider this is a vector. Yes, so that's a vector A. So which has, so its x direction x cap, and then in the y direction it is y cap, y j cap. In the x direction its magnitude is x. Yes or no? X distance, it is in the x distance. So in the y direction it is in y distance. So that's why x I cap along the x axis, y j cap. Okay, so let's suppose this vector is making some angle theta, So then from there we can write the tan theta is equals to, so the tan theta is equals to what we can write? So the y by x. So that y by x, or else we can simply write, so the ay by ax. So the component in the y direction by the component in the x direction. You can write that also. Yes or no? Ay by ax, or simply y by x. Y in the y, so x in the x direction. Clear, everyone? So just remember this one. This is a position vector. The position of any vector with respect to the origin. From origin, how much distance the vector is. In the x, it is x distance. In the y, it is y distance. That's why x I cap plus y j cap. So if I simply, for example, if I write for your reference, let's say this is the x direction, this is the y direction. So there is some vector, some point is there here, so which is having the coordinates 3, 4. So then the position of this vector, we represent it as r basically. So let's write the position of that as r we represent. Okay, so the position vector r from O to P, it's a position vector r. So which is equals to, in the x it is in the at a distance 3. So in the y it is at a distance 4. So that's why 3 I cap plus 4 j cap. That's it. 3 I cap plus 4 j cap. Clear? Sure. So let's take one question. So what's the question says here? A particle starting from the origin moves in a straight line in xy plane. So first consider the xy plane. Consider the xy plane. This is the xy plane. So a particle starts from the origin. Origin coordinates are 0, 0. So it moves in a straight line in xy plane. Okay. So its coordinates at a later time are √3, 3. So let's suppose the body has moved till here in a straight line, they said, like this. So it's making the coordinates after some time √3, 3. So that means in the x it's traveled √3 units, and in the y it traveled 3 units. Okay. So the path of the particle makes with the x-axis an angle of. So we have to find this angle. So simple thing. So the just basic maths. So in the y it is covering a distance 3. So in the x it is covering a distance √3. That's it. So therefore simply use the basic maths. What's tan theta? Tan theta is equals to opposite by the adjacent √3. That's it. So tan theta is equals to the 3. I can write it as √3 into √3. So by √3. So here √3 cancel. So the tan theta is equals to √3. So the theta must be equals to 60 degrees. That's it. The theta must be equals to 60 degrees. Option C is the correct one. Clear? Sure. Now, so if any vector is there in the 3D, so similarly its position with respect to x, its respect to y, with respect to z. So in the x it's covered x distance, in the y it covered y distance, in the z it covered z units distance. So that's why the position vector r, which is x I cap plus y j cap plus z k cap. So if you need the magnitude of that vector, simply you can take it as square root of, so the x square plus y square plus z square. That's it. Okay, clear? Sure. Next. So the displacement vector. So listen to this one carefully. So let's suppose this is the origin 0, 0. So O, consider this as O. Now, so at point P till here, so there is a vector R1. Consider this is a vector R1. Okay. So from origin, the Q point is at a distance, some distance. So whose distance is, let's suppose R2. So let's suppose R2. So now, shall I write the vectors of R1 and R2? R1 is one position vector. So which is nothing but x1 I cap plus y1 j cap. Then R2 is another position vector. Position vector means with respect to origin. Okay. So then, which is x2 I cap plus y2 j cap. x2 I cap plus y2 j cap. This is a position vector of second one, Q. Right. So now, so what is the displacement vector? Now the question is, what is the displacement vector? The displacement vector is this one. So the PQ is the displacement vector. So what is that? PQ is a displacement vector. Displacement vector. Okay. So let's do it by the method. So we know that it's forming the triangle. You observe here, this vector R1 and PQ, they are in the same direction, and R2 is in the opposite direction. From the triangle law, we can write like R1 vector plus PQ vector is equals to R2 vector. Yes or no? R1 and PQ are in the same direction. These two are in the same direction. So whereas this R2 is in the opposite direction. So from the triangle law, so these sum of these two vectors must be equals to R2. So from here I can write, so the PQ is a displacement vector which is equals to R2 vector minus R1 vector. So what is R2 vector, guys? So x2 I cap plus y2 j cap minus what is R1 vector? x1 I cap plus y1 j cap. Just I am showing you the procedure. That's it. So directly you can remember the displacement vector, which is x2 minus x1 I cap, y2 minus y1 j cap. So that you can do. Okay. So but from the triangle law, how can you relate it? So that's I am showing here. So x2 minus x1 I cap plus, yes. So then y2 minus y1 j cap. So this is a displacement vector PQ. That's it. Clear? Chalo. So let's take one question. The last question for today's session. So what's the question says? See here. A particle is moving such that its position coordinates xy are 2 meters and 3 meters. So its xy positions in the starting are 2 and 3. 2 meters and 3 meters at time t is equals 0. And 6 meters and 7 meters at time t is equals to 3 seconds. And 13 meters and 14 meters at t is equals to 5 seconds. So they are asking average velocity from t is equals to 0 seconds to t is equals to 5 seconds. So body initially starting from this point at time t is equals 0. So then finally it is reaching at t is equals to 5 seconds. It's making the coordinates of how much? 13 meters and 14 meters. Right? So this is a time taken from here to here, 0 to 5 seconds. So now the question says that we have to find the average velocity. So we have to find what is average velocity. The average velocity is nothing but total displacement by total time. The average velocity is nothing but it's a total displacement by total time. So total displacement means final position minus initial position. So let it be the initial position R1, let it be the initial position R2. So then R1 has a vector 2 I cap plus 3 j cap. R2 has a vector, so 13 I cap plus 14 j cap. You can write it here. So R1 has a vector which is 2 I cap plus 3 j cap. R2 has a vector, so which is 13 I cap, so 13 I cap plus 14 j cap. Right? So then the total displacement is nothing but final position minus initial position. So what is the final? R2. So what is the initial? R1 by the total time taken 0 to 5 seconds, which is 5. So simply R2 is what? 13 I cap, so plus 14 j cap minus, so what is this one? 2 I cap plus 3 j cap. So by the time taken, so 5. So which comes out to be, So 13 minus 2, 11 I cap. So 14 minus 3, 13 minus 2, 11. So this is also 11 j cap by 5. So which comes out to be 11 if you take common. So 11 by 5 I cap minus j cap. 11 by 5 I cap minus j cap. Okay, so this must be minus. So this must be minus, guys. So option total displacement, right? So what's the total displacement? This vector, yes or no? 13 minus 2. Sorry, this is plus only. My bad. Sorry guys. This minus this one, right? So then it's going to be plus only. So 13 minus 2 plus 11. 14 minus 3 plus 11. Yes. So by 5. So this is going to be I plus j only. So option D is the correct one. Clear? Understood, everyone? So till here. So that's it about the vectors part for today's class. And again in tomorrow's class we are going to see the product of vectors, scalar product, which is the dot product, and the vector product, which is the cross product. Okay, so that we'll see it in the next class, and we'll also introduce the relative velocity in the next session. So till then, keep studying. All the very best, guys. Bye. Take care.